and welcome to the Cordis webinar. I'm Rob Clippard, Chief Marketing Officer here at Clippard Instrument Laboratory, and I'm excited to share some great information about a great team that created a really great product. Clippard has a long reputation of being an excellent manufacturer of miniature electronic valves. In fact, we originated, designed, developed, innovated the spider technology. That technology really revolutionized our industry in terms of setting a new standard for leak rate, reliability, and extremely long life, billions of cycles. We've made millions of these valves in tens of thousands of applications and have even become the standard within industries that like to beat valves up, such as electronic pressure controllers. This is an industry that we've been serving for a long time and will continue to serve, but as a natural progression of our own product line, Clippard has developed our own EPC, the Cordis. Cordis, it is Latin for of the heart. It is something that we're super excited about because the spider technology is at the heart of our valve, and this valve is then at the heart of our EPC, and soon we certainly hope that Cordis is at the heart of your product. So joining me today is Matt Larson. Matt has headed up the team developing the Cordis product, and will be sharing with us momentarily all the points and topics and a little overview on the Cordis. Also, we'll have Chris Robbins. Chris is our design engineer manager, who really is key and clutch to designing such an innovative product here. And then we have Doug Painter. Doug is he's been with us for about 10 years now and was recently promoted to the product manager for the Cordis line because Doug actually came to us 10 years ago with extensive experience selling and applying EPC product. So with that, Matt, take it away, and I hope you guys enjoy.
Thanks, Rob, and hello, everybody. Thank you for taking the time out of your day. What we want to discuss today is the 6 key characteristics of Clippard's new electronic pressure control unit called the Cordis. The first one we're going to talk about is accuracy. The second one is repeatability. The third one is resolution. The fourth is stability. The fifth is PI flexibility. And the sixth is dynamic command changes. These are all key characteristics of the Cordis that we want to review with you today. So first, let's review some of the key components of the Cordis electronic pressure controller. One being the proportional inlet valve that gives us finite pressure control going up. Second being the proportional exhaust valve, gives us finite control going down. Third being the pressure sensor, which is always looking at downstream process pressure side. And the fourth being the circuit board, which includes a microcontroller with our proprietary software to bring all these things together. So now I'm going to pass you over to Chris Robbins, and he's going to give you some brief examples on the 6 characteristics.
Thanks, Matt. We'll begin with accuracy. Accuracy is pretty simple yet foundational when it comes to the different aspects of the Cordis. Accuracy in a pressure controller is defined by variation from the output measurement of the pressure sensor compared to the known actual value. If I expect a pressure sensor to be calibrated 0 to 50 psi and it reads 49.5 psi, when I confirm that I know I have 50 psi, its accuracy is 0.5 psi or minus 1%. Percentage accuracy of Cordis is plus or minus 0.25%, a full scale calibrated range. So if the unit is calibrated 0 to 100 psi, then the accuracy would be plus or minus 0.25 psi full scale. But if the unit is calibrated 0 to 5 psi, the accuracy would be plus or minus 0.0125 psi. Cordis uses an internal sensor that is temperature compensated. This allows for a wider temperature range to reduce the drifted pressures. The plus or minus 0.25% of the sensor specification, normally we see much higher accuracy with the dual proportional controls.
Thanks, Chris. An application that will cover accuracy will be our ability to control very low pressures in an application like leak testing. We want to do inches of water column pressure control into parts like a cell phone or light bulb or something like that that requires low pressure. The object of the game, though, is for the flow meter to monitor the leak rate of the part. There's an allowable leak rate. We obviously want zero leak, but the flow meters are looking for maybe 5 SCC of maximum flow before the part can be passed or failed. The Cordis product, utilizing proportional valves, is able to maintain a very, very accurate pressure control into these parts. Other manufacturers of proportional regulators have difficulty approaching these types of applications simply because the resolution and accuracy cannot be achieved. So the Cordis product and Clippard are looking for these type of applications. Back to you, Chris.
Next, we'll talk about repeatability. Repeatability can also be referred to as precision. The act of repeatability is performing the same tests around the same parameters and getting the same results. Where this could be beneficial is in an application where the customer is mapping the process, whereas they rely on giving it a certain command signal and knowing that it's going to reach that value every single time. If it does this as a control scheme, they're able to write a command set to know that they go to that command and that they're going to get repeatable and accurate results. So what we're going to demonstrate here is the control scheme we have set up here. This is providing 0 to 10 volts. We have a moderately regulated inlet pressure of 80 psi to a 60 psi unit. We're looking at the drive as a pressure indicator. So what I'm going to do is I'm going to decrease the value of my 5 volt command to 1 volts and then bring it back to 5 volts and look to see the repeatability of the Cordis product. So I'm now commanding 1 volt, 6 psi's target. 29.94 was my mark. And as it settles out, we're 29.93. If we increase the command signal to 8 volts, just to give it an accelerated command, and we bring it back down, again, 29.94 was our target. We're going to settle out here at 29.91.
Chris, that was probably the best way to describe repeatability. I've got a whole host of different applications to call out repeatability. But we all know that repeatability is typically the most important part of any application. So showing one application doesn't really do repeatability justice. I think if our customers are going to be very comfortable in the fact that we have a 500% repeatability that we can stand behind. I don't know what else to say about repeatability other than we do it very well. Thanks, Chris.
Thirdly, we'll talk about resolution. Let's define the resolution of an EPC of how finite control you have throughout a control range. One of the ways that Cordis is unique in resolution is that it uses 2 proportional valves, one on the inlet, one on the process exhaust side. It also is a combination of an integrated microcontroller, proprietary software, and the 2 proportional valves that allow us to have the exceptional resolution. The Cordis can control pressure steps as little as 5 millivolts. For example, with this 0 to 60 psi Cordis device, calibrated 0 to 10 volts command, you can expect to see a change of 5 millivolts to equate to 0.03 psig. This is exceptional resolution.
Thanks, Chris. That is exceptional resolution. However, I want to break it down a little differently this time. There are 10,000 millivolts within the 0 to 10 volt command that we're working with. So we just told you that we can do 5 millivolts. That is 2,000 points of resolution within the 0 to 10 volt command. So if I take that and I'm working with the 0 to 15 psi range, I divide 15 psi by 2,000, and that's going to give me a 5 millivolt is equal to 0.0075 psi. That's pretty phenomenal resolution. So we talk about resolution. We're going to go into an application now. We're going to, resolution is very important in a lot of things, but in this particular case, we're talking about 3D bioprinting. So we're utilizing the unit to push the fluid through at a rate. And any kind of fluctuation in downstream pressure is potentially damaging to the media that's within the vessel that they're trying to push through. It could be where we change the pressure because of the speed of the system or whatever the case is, but the resolution that we're controlling downstream, that 5 millivolt capability, that plus or minus 0.0075, that's a phenomenal downstream pressure control. That is phenomenal resolution. My understanding is other manufacturers they work with 20 to 25 millivolt per volts. We talked about the math. You can see where we're different. Thanks, Chris.
The fourth one will be stability. An EPC stability is a characteristic that allows the output pressure to quickly get to your set point with little or no oscillation. Stability under both static and dynamic conditions can be tricky. Some applications call to just fill a static set pressure, which is fairly easy for most electronic pressure controllers. But when you factor both scenarios in the same application, that ain't very simple. This requires a unit to react in both static and dynamic states. As the EPC automatically compensates to increase or decrease for pressure in either dynamic or static states, hunting with no oscillation can become more complex with the application where fast response is required. This is where the Cordis is different. The Cordis automatically compensates based on the feedback being fed from the internal sensor to the microcontroller around the proprietary software. But this allows for outstanding dynamic and static control with little to no changes to the proportional and integral values. So for example, let's take the minimum volume of 0.5 cubic inches and let's fill a specific volume in a static condition. Notice that there's stability here, and now we plug a small leak downstream. And you'll notice the output pressure of the Cordis may have blipped, but is stable under both static and dynamic conditions by opening and closing this valve, allowing pressure to bleed to atmosphere.
Thanks, Chris. Another application that we need to discuss when it comes to stability is mass producing parts. They need very, very accurate. They need a high resolution, but they need the stability so that they can test one part after another as quickly as possible. All the things that we're talking about regarding the Cordis, the resolution, the accuracy, the repeatability, all that goes into a stable output pressure. And as long as we can provide a stable downstream pressure and be able to adjust as soon as possible, now the testing in the application can start. In this particular case, we're talking about pressure sensing. The company makes their own pressure sensors, and they have all different types of pressure ranges that they want to work with. So they'll cascade all the units in line to depend on the resolution of each of those units. So each one of those units will be set up a little bit differently because of different pressure ranges and all that, but they all need to settle and be stable at the same time so that they can get their parts through that system as fast as possible. That's a great example of stability. Thanks.
Our fifth characteristic will be performance flexibility. Performance flexibility to Clippard is providing a proportional and integral platform that allows the end user or customer to make changes as the applications change or variables unforeseen may arise. So by definition for Clippard, we look at the proportional as the error value between the commanded set point and the actual output pressure sensor. We look at that error, we multiply that by a given factor, and that helps with response time to get to your set point. Integral is the accumulation of the sum as the error continues while you're at a static pressure. So this is in helping with accuracy, resolution, and ultimately stability. The Cordis offering the flexible proportional integral platform provides the end user to make adjustments to enhance the Cordis performance.
Although Clippard strives to ship unit outright the first time, we understand that in a prototype phase, typically that we're in, parameters change. It could be a calibration, it could be volumes, whatever that might be. The performance flexibility option that we provide you gives you the ability to actually make those changes there at your facility. This is time and money saving option for you. You're going to be able to manipulate the unit how best fits your application. So you want to do that, you simply take your laptop, link into the Cordis unit, make those changes, and you're off and running. Back to you, Chris.
Our sixth and final point today is dynamic command changes. Always listening is a Clippard term that refers to how the serial port can be used to make changes on the fly once installed into a customer's application. We've talked about the performance flexibility of the Cordis and the ability to tune it yourself and as these applications may change. But always listening feature isn't just for the initial setup of the application, but for dynamic changes in multiple applications with the same device.
So we've discussed the qualities that the Cordis product brings to the table. The accuracy, the repeatability, the resolution, stability, performance flexibility. What if I have multiple jobs that I have to do in this particular application? Those jobs might be different calibrations. Could be anything. But now with this dynamic command change capability, your controller can send a recipe or a command to our unit that is completely scaled differently than what the unit is in the original packaging. Maybe it's 0 to 15 psi, but you need to change it to something else. That simply can be done because we're always listening. Just like my boss.
Whoa, huh? What? Sorry, I was...
Really?
So anyways, thanks Doug and Chris. We really appreciate the time and this going over the 6 characteristics with us of the Cordis electronic pressure control unit. Before we wrap up though, I want to highlight a few items that I have here. One of them being, at the end of this month, we'll be releasing the 0 to 500 psi unit. So to have a calibrated range of 0 to 500 with a max inlet of 550. One other thing I want to mention too is we can do full vacuum or vacuum through positive pressure. So don't shy away from those types of applications. One other thing too to make sure that you understand is that we can go as low as calibrated pressure of 0 to 4 inches of water. There's not a lot of players in that game, so if you come across those applications, let us know. One other thing too is external feedback. So basically, if a customer has a unique application to where they need to take a feedback from a downstream sensor, we can take that feedback. As long as it's a 0.5 to 4.5 volt, 0 to 5 volt, and 0 to 10 volt, then we'll have no problem with that application. Wanted to give you a little bit of a sneak peek of an upcoming product that's going to be coming out later this year. And instead of closing the loop around pressure, we're going to be closing the loop around flow. We're very happy with this. It works really well, especially in those low flow applications. So please let us know now if you start coming across those types of applications. So we're all very excited to share this information. We look forward to working with you very soon. So now I'm going to unfortunately have to pass you over to Rob. So.
Thank you, I think. So obviously it's a great team, great product, and you can tell that we have fun. And so we appreciate you guys watching today. But before I jump over to questions, I think that it's important to just end on another note here that I've already talked and led with the fact that we have a proven experience as the manufacturer of the valves that are used in many other EPCs. And again, I think this is a really important differentiation that we have here at Clippard. So we're excited to not just share a lot of experience. In fact, some of the best people in the industry you just heard from, and gaining the reputation of being the leader in the EPC market is exciting to us. But again, that additional benefit to you as a customer is the fact that we produce the valve, the manifold, a lot of the components that go into this ourselves, and we have that experience and expertise, level of quality. And it's something that is a competitive advantage for you in terms of our responsiveness, our expertise, even down to the flexibility of applying a customized product into this. as well as delivery. It's something that we're looking forward to serving you. Everyone here at Clippard is excited to serve excellence and really rally around this product. And so again, thank you for watching, appreciate it, and we're looking forward to working with you on an application soon.